Hello everyone, welcome to Caltex Academy. Today we're looking at implicit differentiation. Implicit differentiation is the opposite of explicit differentiation, and we have been looking at explicit differentiation when we're given function like f of x equals to x squared plus 2x maybe plus 4. Now here for explicit, we realize that the variable in terms of x, or one variable, is attached to f of x. It would be y equals to x squared plus maybe 1. So one variable is in the set of domain and the other one is in the set of range. That is what we refer to as explicit, and I think we're comfortable with this differentiation. But with explicit differentiation is a different case, where two variables would appear in one side and you're expected to differentiate one of the variables with respect to the other, just like the y with respect to x in this example here. So with implicit differentiation, we need to have some knowledge of chain rule and product rule. And I've linked some videos in the description of this video here. You can go ahead and watch about chain rule and product rule if you are curious to continue with this. So today we're looking at a simple version of implicit differentiation where we involve only chain rule. And don't worry, I'm going to walk you step by step slowly from grounds up. Now with all this said, let's get started. Our first question is x squared plus y squared equals to 9. Now here we can differentiate with respect to x, and this is the style of writing. So we have x squared plus y squared, meaning we're differentiating the left hand side with respect to x. Then we also do the same to the right hand side. Here the derivative of a constant of course goes to 0. Now let's distribute this derivative to these two terms on the left hand side. So we have dx of the first term is x squared, then plus dx of y squared equals to, so the derivative of 9 is 0. Then having written this, we can move on with our differentiation. So the first thing we need to do is to see whether x is corresponding with what we have in the denominator. If it is, then that is the normal differentiation, something like this. So let's go ahead and have this. The derivative of x squared is 2 x, then plus, but when you look at this one, we have y square and x. So this is where chain rule comes in handy. Now how do we apply chain rule? So we write derivative with respect to y, and then also maintain derivative of the y with respect to x, because our major aim is to get the y by the x. So let's put it in action, and we have here the y of our function y squared, and then times dy by dx. As you can see, the chain rule, this dy and this dy will vanish, and you have something dy with respect to x. So this one is equals to our 0 from the left hand side. Now let's differentiate that. The derivative of 2y, y raised to 2 is 2y. Then with our dy, dx attached to it, so this is equals to 0. So our main aim is to isolate this dy dx alone. So we can collect left terms, taking 2x to the other side. So our dy by dx with our 2y attached to it equals to negative 2x. Now dividing both sides by 2y, maybe I can switch it here. Our dy by dx should be equals to negative 2x over 2y, and we can narrow down this 2 here by dividing it through. So the remaining term for our derivative is negative x over y, and that is the answer to the first part here. In case you are a little bit lost, don't worry, by the time we finish these 3 examples you'll be comfortable. So at the end of this video I'm also going to give you some exercise for you to try. Please go ahead and try it and share your answer. So let's move on to part number 2. In part B we had x cubed plus y cubed equals 64. Then we do the same, writing dx of the whole of this term plus y cubed equals to dx of 64. Then distributing from the left hand side we have dx of x cubed, we can close it, plus dx of y cubed. Then this will be equals to, now the derivative of 64 is 0. And we can do the same here. This is the normal derivative. We shall have it array x, the power is reduced by 1 to 2, plus, then we repeat the same scenario what we did earlier on, where we differentiate with respect to y first, that function y cubed, and we multiply by dy by dx equals to 0. So let's differentiate here, while copying our 3x squared down. So the derivative of y cubed is 3y squared, with our dy by dx attached to it. Collecting a term as we isolate dy by dx away, it results to negative 3x squared. Then dividing both sides by 3y squared will result into this expression. Also our dy by dx will be, now we can see also 3 is common to numerator and denominator. We can cancel it out and write the remaining terms here. That is x squared over y squared, and that is the answer for this act. So part C is 2x squared plus 2y squared plus 3x equals 10 plus 7y. By the way, this is equation of the cycle. Now we can move on and do the same work, where we have dx of 2x squared plus 2y squared plus 3x. We're done with the left hand side, we move to the right hand side and also differentiate with respect to x of 10 plus 7y. Now on distribution, we realize that we have the first term here, dx of 2x squared, and then plus dx of 2y squared plus dx of 3x equal dx of 10, and finally dx of 7y. So we can differentiate the first term here to 4x, then the second term, now this term let's differentiate directly. So we have here plus 4y, and remember this one is y while we are differentiating with respect to x, so we have to attach our dy by dx here. Then this one is differentiating to 3 because we have x everywhere here. Then on the other side, derivative of 10 is 0. Plus here also we employ chain rule, so we have derivative of 7y as 7 dy and dx. Now let's join this component with dy by dx to the right hand side, and we're left here with 4x plus 3 equals to 7 dy by dx minus 4y dy by dx. So we can factor out from the right hand side our dy by dx, and we are left with 7 minus 4y divides dy by dx. So dividing both sides by the coefficient of dy by dx will yield for us 4x plus 3 all over 7 minus 4y, and that is the solution for this part. So now that we have learned all this example, let's go ahead and have some checkpoint, and then I'm going to give you the answer and struggle to look for the answer through working. And then in case you get some challenges, feel free to drop me some comment and I'll get back to you. So let's get to the checkpoint. Now here's the checkpoint. Please go ahead to prove that your answer looks like this, and if you got it correctly, congratulations for doing that. So stay tuned for the next part where we're going to advance it a little bit. We will be integrating both product rule and chain rule in our next example. So meet you on the other side. Ciao.